Good evening, everyone, and welcome to Griffith's birthday. I'm getting ahead of myself. Griffith Observatory to the 10th anniversary celebration of All Space Considered. How many? This is a, wow, thank you. This is a crazy question. Is there anyone other than us who was at that show? Anyone? Yeah. Okay. I probably not.
One
really?
One man in the back. Yeah.
Oh my gosh! Thank you.
There
Who
you
was
go.
that? Me. Well, me. I am so grateful that you have come to this show all these times.
You don't look a day over 9.
Oh, thank you very much. That's very nice. Yeah, that just, okay, show's over. So we're going to just do a rundown of the last 10 years, sort of highlights and milestones. Lowlights. And we'll begin with 2008. Again, where were you in 2008? Well, there was a lot going on. We had a change of administration. We had a crash in the housing and stock markets. And most importantly, the Giants beat the Patriots. Yay! Excellent. Ooh, I hear some hisses there. Anyway, there are a few other things that you might remember from that year, but perhaps the most exciting thing is that there was this circle around a piece of land in France and Switzerland. And if you're wondering, what am I talking about? That is not actually a yellow circle drawn on the Earth, but what it indicates is what's below the Earth at that point, which is the Large Hadron Collider. It is a super collider. It bangs together particles and makes showers of other particles so we can study elementary particles. And it was turned on in 2008. There was a lot of consternation about this. There were people who thought, and some who theorized that, or I should say hypothesized, that, that if we turned on the collider, little black holes would be formed. They would gobble up each other and become bigger black holes, and within a matter of a flash of a blink of an eye, the entire world would be consumed by a black hole. And there were petitions to not have it be turned on, because we didn't want the world to end. But, but you know, there were a lot of arguments why that wasn't true. They went ahead and turned it on after quite a lot. No one would do this lightly. Let me just say that very carefully. The short version is that we get a lot of those interactions in our atmosphere all the time anyway, those particle showers, and black holes don't get formed. So we know experimentally that it was not true. So it was safe. We turned it on. The world didn't end. But in fact, there was a lot of great science that came out of it, and we'll talk a little bit about that.
Yeah, we sent a lander to the polar regions of Mars, actually. We had tried to do it before and it crashed. They used spare parts and it managed to land there. It had a scoop on the front of it. You can see it coming in right here. Believe it or not, they caught it in the foreground of this crater. It didn't land in the crater, and there a blow-up of it is with its parachute. So pretty cool. We have orbiters that can take pictures of the other spacecraft, new friends arriving. There it is on the ground. The orbiters also took a picture of it on the ground, making sure that the solar panels deployed. They certainly did. Soon after getting there, they took a shot of underneath of what was going on, and they saw these sort of hexagonal plates. That's not a home plate, that's actually frozen water. So very cool. It was sent there to find frozen water, and the rockets upon landing unearthed it. It was right there. Another weird thing they saw was some things that looked like droplets along the leg in the upper left there. And they kind of seemed to merge and join and do strange things. And they thought, how can there be liquid on Mars? Well, it turns out the rocket engines use perchlorate. They use certain kinds of salts. Maybe Mars itself has some perchlorates there. And if you mix these with maybe some ice that melted when it landed, maybe you could keep liquids there. People were making up all sorts of stuff. We still don't know. We do know that it had a scoop in the front of it. It dug a whole bunch of trenches, and in some of those trenches, there were little solid things, and then they went away just a few days later. 4 Martian days later, they were gone. They sublimed. Water ice can go from solid directly to vapor. That's what we think happened. We think those were little chunks of water for sure. They were able to do chemistry analysis, and they saw water. They learned about it. So we think we know where some of that water that was in that Martian ocean went because of this mission.
And Mars wasn't the only planet that we visited. In 2008, the Messenger mission arrived at Mercury to start. It was there for many, many years and many discoveries to come. But it did arrive at Mercury for a long-term study of that world.
Yeah, we took a picture of a planet. There it is. This is Fomolo B. And We knew it probably is a planet. There's a little bit of debate of was it dust, was it a planet, what was it? I think we finally settled it's likely to be a planet. But there it is in 2004. 2006 it had moved, and seems to be consistent. But that's the first picture of a planet in another solar system that we've taken.
Okay, SpaceX achieved its first success of putting a satellite into orbit with its Falcon 1 rocket. Launched a small satellite from Malaysia.
Great. Moving on to 2009. It does bring it back, right? The Miracle on the Hudson, and Kanye is still in the news. For many of us, it was sad to say goodbye to Michael Jackson. And the Lakers, you got to acknowledge the Lakers. But anyway, moving off of these sorts of things and onto the science.
Well, remember I mentioned the Constellation program. Well, President Obama announced he was suggesting that that be canceled in 2009. So in that year, NASA did have a test launch of what was called the Ares 1X. It had a mock-up of the Orion capsule, a mock-up of the upper stage, space shuttle first stage, and maybe trying to get some support back for it. And it launched. See a beautiful image of it, the next slide. And then the working part, which was the solid rocket booster, stopped working when it ran out of fuel, and it kind of fell apart, as we'll see next. So not really significant because the upper parts were just dummy pieces anyway, but it didn't look quite as glorious as the buildup.
And 2009 was the International Year of Astronomy. It was one of those sort of UN declared years, like the International Geophysical Year of 1957, for those of you who remember that. It was to celebrate the 400th anniversary of Galileo first taking a telescope and looking at the skies and seeing evidence by looking at the planets in our solar system that Copernicus's view of the solar system was correct. Not the ancient, the dogma version, but the scientific version as put forth by Copernicus. So that was, of course, a huge turn of events, and some people look back at that as the start of Western science. But to celebrate the International Year of Astronomy, had star parties and all kinds of celebrations all over the world, including the first star party on the lawn of the White House. Yay.
We had 3 new space missions launched, the Herschel, Planck, and WISE missions. Herschel looked at long wavelengths. Planck looked at the far, far, far cosmic microwave background radiation, the glow of the birth of the universe. And the Wide Infrared Survey Explorer surveyed the entire sky several times, found lots of asteroids, found lots of cool brown dwarfs and stuff. And it was brought out of UCLA. That's where it was housed, or the folks running it are from UCLA.
Both India and the United States sent satellites to the moon and confirmed that the moon has water, both mixed into its crust, and the American impact mission discovered that there was ice actually in the permanently shadowed craters of the south pole of the moon.
And it's important to say that's not a picture of water. That's showing where the water was observed. Yeah. But they colored it blue. I think they like to do that to give people hope.
This has been important with discussions of people going back to the moon. It means the moon might have resources that could be useful someday.
We did find our first exoplanet that was kind of a little more like Earth. It was rocky, only a little strange. It was Coro 7b. So you can see here it's bigger than Earth. Also, it was really close to its star, so it's hot and super, super dense, and it might be entirely made of iron. We did, well, still, it's pretty cool. In this beautiful launch here, we did launch another exoplanet hunting telescope, the one I showed in the beginning, the Kepler Space Telescope, that has a lot. You'll hear more about it coming up.
And we started inviting guests to come to All Space Considered. So here are some of the guests we had. I'm going to apologize right now. I thought we did such a good job with diversity, but boy, building the slides for the show, we have to do better, and we will. But you'll recognize a couple of people there. Einstein, he was a really good speaker. We loved having him. And this was our first guest, John Clark, who spoke about the shrinking of the ice in the Arctic. A wonderful talk. Andy Chaikin spoke about Mars and several other wonderful guests. Don Lincoln, who is here, a particle physicist, told us all about what the Large Hadron Collider was going to do once it turned on and didn't kill us all. So 2010, people started wearing meat dresses, and you can see there was an unfortunate feud between late night hosts. In the meantime,
the
Kepler turned
mission.
on.
Yeah, Kepler turned on, and right away we saw that it was working. That's its first light image. They saw some clusters in there, and they confirmed the planets. So it was working, which is pretty cool. And they told us about some candidates, but nothing very confirmed yet. So you'll hear more.
And the Solar Dynamics Observatory has a lot of missions. I hope they're getting the sense that there's a lot of activity. There was. So there's people who say, oh, NASA is dead. I think they're not quite right. Anyway, the Solar Dynamics Observatory started providing beautiful images of the sun, and we could honestly spend, a half hour just going through some of these breathtaking images, just because they were so stunning, so high resolution. We learned so much. It wasn't just that they're beautiful, but we learned a lot about the way in which the sun works, which, is really important because it's what keeps us all alive. So that's just a nice image of a big prominence coming out of the sun and the Earth to scale. So yes, we depend on the sun, and not only just for life, but also to give us jack-o'-lanterns when we need them. So it also provides us a lot of heat to our planet.
Yeah, and during that time, 2010 was the hottest year on record, So you can clearly see that we surpassed that. And just a map of where it was really warm. Those red dots represent the warmest areas of the Earth, and the coldest, the blue dots.
And I don't know what happened that year, but we only had one guest, so he gets a big fanfare.
Yeah, a friend of mine, James Bullock, was graduate school with me. Standard Irvine, a professor down there. So.
And David grabbed a picture of it on the monitor and tweeted it at him, and he said, oh, I want to come back. So I think we'll look for him either in the rest of this year or starting next year. We'll have James Bullock back. He's terrific. So the following year, yeah, I know. Oh, I'm sorry. I guess I better go away from that.
How could you show Hogwarts burning? It's so wrong.
So wrong.
We saw the end of the space shuttle program with the last landing of Atlantis.
Yeah, so that was pretty momentous because it was the last time NASA sent.
The space shuttle really was sort of the continuation of the inertia started back with the Mercury and development of the Apollo program. And so now we're without that, I think.
Yeah, that Kepler telescope, here's the field of view with the 3 planets we knew about in that field of view before. Well, they came with another release, and here's what they provided. Another 1,200 on top of the 700 so they gave us last time. They're even finding Earth-sized ones. Those are the blue dots, super Earth, so 1 1/4 to about 2 times Earth size. These numbers are rough anyway. You'll hear people throw out super Earth, and different people use different borders. But there were lots in the field of view, so people were very, very excited. We noticed that lots of them were Neptune-sized, which was different than what had been found before. Previously, we were finding lots of Jupiter-sized and bigger, and now we're starting to find lots of super-Earths, Earths, and Neptunes. So it was a good sign of things to come.
And in 2011, we had the beginning of a series of reports that the Voyager spacecraft left the solar system. Now, for those of you who might not remember Voyager, it was launched in 1977, explored the outer planets, and went on to have a mind meld with Spock. And if you're wondering, what is she talking about, that maybe this will help. There's Captain Kirk looking at Voyager, which became a sentient being that then became, started taking over everything. But anyway. Spoiler, right. But did they make it out? That's what we have to wait. Okay, so anyway, Voyager, also well known because it has this beautiful record of humanity's existence now traveling into interstellar space. So when did it cross to interstellar space? This is the question. There's its mission inside the solar system, but when after a while it passed out of that deep blue circle there is what's called the termination shock. And what that means is that the solar wind blows a bubble, and where that solar wind kind of gets pushed back by the medium around it is what's called the termination shock. This is a nice, very easy, simple physical example of how that works. We've all seen it every time you've done your dishes. So it had passed through this termination shock a decade earlier, or around 2004, and now is in this sort of unknown zone. But there kept being announcements. All of the solar wind velocity had gone basically down to zero. They turned the spacecraft trying to say, well, maybe it's just changed direction, and couldn't understand, what they were finding, but they knew something was up. And so the following year and a half was a debate: are we in the solar system, out of this solar system, or not? And I'll come back to this in a future year.
The Dawn spacecraft finally arrived at the asteroid Vesta, which is the second largest body in the asteroid belt. It went in orbit for about a year and mapped its entire surface. As we can see in the next slide here, the two sides of asteroid Vesta, and showed us a heavily cratered kind of asteroid, and almost spherical in shape, although the gravity couldn't make it quite there because it didn't have quite the mass to go into a perfect sphere.
So it's not a dwarf planet.
It is not a dwarf, yeah.
But the Dawn spacecraft does have a single ion engine, so it's a Psi spacecraft, not a TIE spacecraft.
Yeah.
It is May the 4th, sorry.
Maybe.
TIE Fighter's twin ion engine. Give me that.
Although it took 4 years to get them.
Come on, people.
Thank you, Jeff. We had some wonderful guests in 2011. Everyone will recognize Brian Greene on the left, and next to him, Matt Gollenbeck, who did a fantastic presentation about the selection sites for the landing of the Curiosity mission. We had hot dogs. We had, what are they called, cupcakes that night. Was anybody here that night? Yeah,
Cake
yay,
wars.
cupcakes. And Joao Teixeira, second from the right, is a climate scientist from JPL. He came actually several times to help us work through. This is really in keeping with what Patrick's sort of featured topic was, because it was such a politicized issue that we here at All Space Considered thought we have to get the politics out of it. We've got to talk about the science. And he came back several times to work through not only what the data say, but what the models say, and what is it that we can take away from our what we're learning about Earth's climate. So we were very grateful to have him. Moving on to 2012, I just Gangnam Style guy on the moon is a little bit too much for me, but thank you. Was that a Sarah one? I think that was a Jeff one. Oh, thank you. But actually, there's a reason why we have the moon here, and that's because we've got this one picture. That's Neil Armstrong, actually, one of the few pictures of Neil Armstrong actually on the moon, and of course, that was the year that he passed away. But 2012 is another year that we didn't all, die, which is good, because there were some who thought that that might be somehow written into the prophecy of a Maya stone tablet, and so there was this big December 21st event. We had a party here just to make sure that we made it past midnight onto the next day, which we did, amazingly enough. We even had a little drum roll and a big gong. Was anybody here for that? That was so silly. But it was a lot of fun, and look, here we are to survive to tell the tale. Now, the Large Hadron Collider, which had turned on earlier, started discovering lots of different particles, and there's so many particles that maybe the easiest way to keep track of it is through plushies. Basically, a lot of interactions of quarks and leptons, which is, quarks are the things that make up protons and neutrons. Leptons are like electrons. But there are other particles called bosons that are also, can be described by particle mathematics that describe particle interactions. And so we went looking for one in particular called the Higgs boson, named after Peter Higgs here. And the big announcement was that we found the Higgs boson. There it is. There's the big deal. And it is a big deal, because had they not found it, we would have had to toss out our standard model or greatly revise our standard model for existence, for particles and matter. And I've talked in here many times over the years about the importance of a theory, that a theory is not a fly-by-night, lightweight idea. A theory is an idea, a hypothesis that has been tested and tested and tested so many times that we actually have come to believe that it's passed just about it. We can't think of any more tests. We keep testing it to find ways. If you fail even one test, the theory's out. So if we hadn't found the Higgs boson, which was predicted by our standard model of elementary particles, we would have been in, I think the term is deep doo-doo. So that little bump was very, very exciting, and above all excited was Peter Higgs himself at the announcement.
In the region of 125 GeV, they combine to give us a combined significance of 5 standard deviations.
So SpaceX achieved yet another thing, this time using the Falcon 9 to fly the first stage back when it was done delivering the second stage on its way and coming back to Cape Canaveral. Oh, I'm sorry. This is except
well,
that actually will have that's in the future. That's still in the future. Forget you heard that.
Yeah,
no.
Roll back.
Once you've seen one Falcon 9, no. This is the first launch of under NASA contract of the Dragon resupply mission, and so it took Dragon to the International Space Station. Here we see the robot arm grabbing it. It retrieved all it actually docked it to the space station, pulled out all the goodies inside, reloaded it with stuff to send back to Earth, and then sent it back on its way to land in the ocean, where it was recovered. And even the capsules can be reused.
So while that forward movement was taking place in at the International Space Station, the shuttles were being retired, and this is a picture of Space Shuttle Endeavour.
Yeah, returning to California at Edwards Air Force Base.
I think, did you take this picture?
I did,
think you
yeah.
did.
That was with
That's
Patrick
right.
and
Yeah.
Emily Lakdawala.
Yeah.
Gave her shade to
gave her shade.
The sun. Yeah, she was
You threw shade at Emily Lakdawala.
well.
Anyway, so here it is. I mean, amazingly, this flies. You can see the light through the windows passing through the 747.
That was taken from here by Bob Spellman, one of our former staff people. Yeah.
Beautiful picture. And of course, it came to be at the California Science Center, so where it would remain on and still is on display. How many of you have seen the shuttle? Yay! That means for those of you who don't have your hands up, go to the California Science Center. It's kind of unbelievable. First time I saw it, I just was like, oh my gosh. And how many of you saw it flying over? Yeah, wasn't that a stunning sight? It was so breathtaking. And of course, it flew over many important California landmarks like the Hollywood sign and everybody's favorite Griffith Observatory. Yay! One of the important things in that image is the crowd that is not over the fire limit at all. And it was a hot day, so everybody was incredibly patient. It was a magnificent time. Anyway, it was we just have way too many pictures in here because it's just too pretty. I took that one. Oh, thank you. That was one of my contributions. And over the Coliseum at USC and the beach, because we're California and we have beaches. And Disneyland, yes, over Disneyland, over Angel Stadium. And of course, it was just flew around a bunch until it landed and then came to the Science Center.
And it took a route from LAX to the California Science Center. It was 12 miles long, and it took a total of 2 days to get to the California Science Center, which is equivalent to 32 orbits of the shuttle in 2 days. It was quite a fanfare. It went through the streets.
How many of you saw that? Yeah.
Although the shuttle's wings were pretty wide, so along the route, unfortunately, some trees had to be chopped and some street lights had to be taken down.
But they were replaced, and replaced with better trees. It's true. I didn't mean that to be funny.
And of course, as it moved along on its on this huge platform, there were loads of people, and especially people who wanted to stop for coffee and donuts also got a view of it too.
Also in that year?
Yeah, we had a very rare astronomical event, a transit of Venus. And there had been one 8 years before, but that you had to be in Egypt to see that, or the other side of the world. And so this was our last chance, because the next one isn't for like until 2117. And actually the ones in that year, I found out, even if you eat right and plan to be around then, from here, the best view we get is only about 20 minutes before sunset. I mean, it only starts 20 minutes before the sunset, so it won't be as good. Venus actually passes between Earth and the Sun. This is a picture through our 12-inch telescope here. You can actually see the atmosphere of Venus refracting sunlight around. It slowly passes across. It takes many hours to go across the Sun. And it's actually big enough that just with a solar filter, you protect your eyes so you can see it without magnification. So it's a pretty big dot.
And if another alien civilization out that away was looking, they would see a transit, just like if they have a Kepler telescope, just like David was describing. So another thing that was kind of important about that for us was that we had our first live stream broadcast. And yay, thank you. We love doing our live stream broadcasts of celestial events. We've done some for lunar eclipses and the Mercury transit, but our first time out we had over 80,000 views, so we were pretty excited about that. Our last one we had over 100 million people saw our feed. So yeah, I know I had to say it because I'm excited about it, because we have our beautiful facility brought to you by the citizens of Los Angeles and friends of the observatory. I would say thank you to you, honestly. So that was very exciting, but even more exciting.
Even more exciting, we sent this rover to Mars. Believe it or not, this is the Curiosity rover as it's being built. Yeah, applaud for Curiosity for sure. We sent it to Gale Crater in that a little black ellipse right up here is where it was targeted to go. Sure enough, it landed in there, and it took 7 minutes to get down, and they released this video, 7 minutes of terror, and we've edited it down to 21 seconds of terror. So.
Look terrified.
Yeah, but that's what actually happened, though. That's the crazy part about it. It did come in, they did deploy a parachute. Mars's atmosphere is so thin, however, a parachute can't stop a heavy rover like this. They needed to use a sky crane. So they had a sky crane with rockets, and everything you saw happened. And that is the first space selfie ever taken by a robot. So, very cool.
Did it break the internet?
It might have. So, that same year, we found a cool planet that didn't orbit 2 stars, but orbited a system that had 4 stars in it, which made us think, okay, there's Tatooine, and then there's the double Tatooine. So, once again, made the 4th win.
More guests in 2012. Because of the Mars landing, we had an all Mars considered with John Callis and Leonard David in the lower left there. There's Joao again. Dr. Krupp, the director of the observatory, spoke about the end of the world, not. And Dan Durda visited us. He's actually come several times, friend of the show. But in the interest of time, I'm just going to move forward to the next year. Yeah, because Candy Crush was the most important part of that. But some of you will remember the Chelyabinsk meteor, and we just pulled together a very brief version of several of our favorite clips, including our favorite rock and roll from Russia. I guess you'd call it rock and roll, I don't know. Anyway, there's the meteor coming in. There are so many shots of this. That was on their feed. First the flash, and then about 2 minutes later, the boom. So, you know, it's kind of funny to hear the booms and everything, but imagine how terrifying that would be. And,
over 1,000 people were injured by the
over
glass.
1,000 people.
Yeah.
Yep. So if you ever see a bright light flashing in the sky, do not go to the window to look at it. And I'm actually being very sincere, because that usually will come with a big sonic boom like that.
Yeah, so that Curiosity rover we sent just the previous year, when it hit pay dirt, used its drill, drilled down in there, put it into its little sample, analyzed it. Turned out, well, it also took pictures of these little pebbles. It found evidence that there were flowing streams on Mars. It found evidence that that water was probably drinkable and had a pH that you and I could drink. And it found all the elements, those schnapps elements that life needs. Right away. So that's the mission it was sent there to go do. It found a habitat on Mars that life could have existed. So now it could just go play and hang out. So anyway, but seriously, within the first year, completing the mission was a pretty amazing thing.
Another big headline was, where does bling come from? And actually, this is a two-part story. So here's again the play of theory and observation. By bling, I mean specifically gold and some of the other elements, high atomic number elements. And if you look at the periodic table of the time, it was thought they came from supernovae. But a paper came out that theorized that, or I should say, hypothesized that in fact it was gold was formed by merging neutron stars, which led us to this very wonderful video, which they made me put in. So then, there. For those of you who weren't here, just never mind. And back to Voyager. Oh, how many times? It has, you know, this has become, it's in the solar system, it's off the solar system, what's the story? I was in this kind of limbo in-between zone, but the short version is, ta-da, it finally did cross over the threshold into interstellar space. And that is amazing. Our first human creation in between the stars. And we had another bunch of visitors. I guess I'm just going to point out Andy Ingersoll in the lower right, because he gave, how many of there were here for the night that Andy Ingersoll told us all about Jupiter and the Juno mission? Yeah, okay, he is a rare treat, and we hope he'll come back. Very candid individual, very fun. Then 2014, it was both a cold year and the warmest year. It's back to its, you know, things getting a little more unstable. Ice bucket challenge, so there's a little bit of a theme there. Speaking of ice, we sent the Rosetta mission caught up after 10 years with a comet called
Churyumov-Gerasimenko.
Thank you, Bill. And for 2 years, we played this music. So I guess we're going to wreck it for you now. Did you hear it when you came in? Nobody ever got it in 2 years, and that is called Rosetta.
That's Waller?
That was Earl Hines.
Thank you.
So after 10 years, Rosetta had slept along the way, woke up, it was approaching the comet. It got there, I think, in the end of August, or middle of August, but as it approached, it saw the comet in the middle and the big coma. And then as it got even closer, we could see it was a double-lobed comet, which made us think, oh, it looks just like a rubber ducky. We even had a rubber ducky here at Griffith Observatory. But to give you the true scale of the comet, that is not the comet smashing into, well, it looks like the comet smashing into Los Angeles, but it's just to tell you the scale of the comet. And we followed that comet around for the next year and a half, almost two, and got to watch it as it came close to the sun and started outgassing materials, creating its tail, and got to watch the evolution of a comet altogether. And the thing we also really loved, and this takes a minute, I'm aware of the clock, but I'm going to let it go, is this series of cartoons from European Space Agency.
To its surface. A long night of final preparations lay ahead of them. Finally, the moment everyone had been waiting for arrived. Philae and Rosetta were sad to be going their separate ways, but excited at the same time, because this is what they had been waiting to do. Philae was away.
Good luck.
So they each took pictures of each other.
So this is Philae's picture of Rosetta. You can see the solar panel of Rosetta as it began to descend to the surface of 67P. We go to the next one. There is, kind of in the distance, a little speck there. And finally, it attempted to land on 67P, but it touched down, and the harpoon that was supposed to anchor it into the surface of 67P failed to deploy, and the rocket that was supposed to fire and to keep it down didn't, so it bounced, and it bounced twice, and then ended up in an area where it was kind of shadowed, and so it just had enough power to take this picture and drill into the surface and give us some preliminary information about the comet.
So a mission to
India
Mars.
sent its first mission to another planet. This is to the Mars Orbital Mission, or MOM. And it was to study, study the atmosphere of Mars. And we thought MOM needed an update here, so. So, and absolutely marvelous mission. It's still actually operating too, and it's complementing what NASA's probes are studying about the atmosphere.
Spacecraft Maven arrived at Mars, and its mission was to study how Mars lost its atmosphere. It has an orbit, and we can go to the next slide, that took it really close to Mars so it can sample some of the gases. And it gave us our first evidence of how Mars lost its atmosphere was due to solar wind, and it happened, much of its atmosphere was stripped away in the early era of the solar system. So we only have a little bit of Martian atmosphere left, 1/100th of what it was before.
The Kepler Space Telescope continued to release data. They continue to give us results, and they're finding lots and lots of exoplanets. They had a 400% increase of the number of Earth-sized planets, a 600% increase of the super-Earths, a 200% increase of the Neptunes, and you can read the little 2%. Now, why is that even interesting? Well, it's starting to tell us that those Neptune-sized and super-Earth-sized, they're common. The Jupiters aren't all that common. We still know more about them because they're easier to find. That's why we have more Jupiters, but in the long run, there's more little ones. We also found a planet that was almost Earth-sized, just a little bit bigger, Kepler 186f. As you see there, it's in the habitable zone. It's around a red dwarf star, so it orbits much closer, but it is about Earth-sized, and you can walk around on it probably, and it might even have liquid water, so a very cool discovery.
And again, we had guests. The principal investigator of the Maven mission that Patrick was talking about on the left, Bruce Stokowski, and Dave Doody talked about Saturn. Emily Lakdawala, who's a friend to all of us and friend to the show. And Zach Staniszewski, their second on the left, brought all of his gear from the South Pole. It was a lot of fun. Then the following year, guess it was the hottest year on record again. And big headline from that year.
Yes, New Horizons finally arrived at Pluto and gave us our first ever view. Before we had views from the Hubble Space Telescope. But here we see a world that is made of nitrogen ices. There's some methane, and rocks are basically the bedrock of solid ice in this world, which is 420 degrees below zero. There is, with its moon, called Charon. And as a parting shot, we saw the atmosphere backlit of Pluto from New Horizon. And now it's on its way to Kuiper Belt object Mu-69, and will arrive New Year's Day next year.
Yeah, that was actually the parting shot,
Yeah.
that's right. And this is a throwback to 1990 of the launch of the Hubble Space Telescope, but we had the 25th anniversary of the deployment of the telescope, which, as you know, had problems at first, which were then fixed for gorgeous images. So we had a big celebration to celebrate 25 years of Hubble and all the amazing, beautiful images that it has brought us, and all the amazing science that it brought us. And then, of course, my favorite image, because I just like that the universe is smiling at us. Oh,
Okay,
Patrick.
after visiting Vesta in 2011, the Dawn spacecraft showed us Ceres, the largest body in the asteroid belt, which is a dwarf planet, and gave us those views of those white specks inside that large crater. We can see a close-up of it in the next one, which are believed to be salt deposits. And also its largest mountain, which is called the Huna Mons, which stands about 13,000 feet above the dwarf planet's surface.
We observed a star that had these weird dimmings to it. It would suddenly get fainter, get brighter, get fainter. They weren't repeatable. It had people hypothesizing maybe we were observing aliens that had built a structure around it to capture that starlight. So The Guardian had a lot of magazines and newspapers had headlines like this: alien megastructure could explain this mysterious result. Others thought, well, maybe it's just dust or comets colliding in the foreground. Others thought maybe it was a giant planet with rings around it and the rings were blocking out the light. All we knew is that it was discovered by an astronomer named Tabitha, and it was called Tabby's star. So, yay. So there's our alien megastructure.
Yeah. And of course, that year is also the year we lost Leonard Nimoy, after whom this theater is named for his generous support of Griffith Observatory, which he loved.
I'm Leonard Nimoy, and I love this place.
So we're very proud of our connection to him. He was a wonderful supporter of the observatory. When he passed, a lot of people just spontaneously brought flowers and put them outside this theater. And we just remember him with great fondness and in the theme of the kitties. Another huge discovery of that year, even though it was announced in the start of the following year, was the discovery of gravitational waves. With this crazy-looking apparatus that has two 4-kilometer-long arms sitting in the middle of an undisturbed area. There are 2 of them in the country, and it was there to look for gravitational waves. So what are those? Well, when we think of space, we think of it just being, you know, right, left, up, down, forward, back, all kind of square and rectilinear, like you learned it from doing your Euclid geometry. But in fact, Einstein showed us that space-time is curved, that space-time is almost rubbery, it's flexible and changeable, and can hide things in it. Another common slide from this show. But in fact, when something energetic happens, like the collision of 2 black holes or 2 neutron stars, it can cause ripples that get sent out through space-time and cause space-time itself to wobble. So you'll see that little jiggle at the end, and those wobbles propagate through space, and eventually they come to Earth, which it's not playing. Well, imagine Earth going wah, wah, wah. Oh, there it is. It must have been yay, okay, good. So those ripples come back, and yes, my favorite part, not somewhat exaggerated, just a little bit, because that would be very rough on our planet. But in fact, that crazy building with the long arms could detect it. And sure enough, they did. So huge, again, had been predicted, was utterly essential for the theory to be correct. And these 3 gentlemen won the Nobel Prize for having done that.
We had 4 total eclipses that began in 2014 and ended in 2015. And all of them, they were sequential. And we saw them all from Griffith Observatory and even videotaped them and compressed them into 1 minute for your viewing pleasure. This was popularly known as the Blood Moon.
And on the last one, we had a fellow playing a Steinway grand piano, the Moonlight Sonata, courtesy of LA Phil.
Yeah. So Falcon 1, now Falcon 9, I should say, finally achieved its goal of reusability by
3, 2, 1, 0.
Launching, and then
Liftoff, Falcon 9.
A few minutes later.
That is that first stage.
And you hear just a little excitement from the crowd.
So the first soft landing of that booster.
So one's going up and one's going down in that picture.
And so after studying it, it looked like it was in good shape. He probably could have reflown it, but must have decided that he had another plan for this booster. And how many of you have seen this? Yeah, if you go down Crenshaw Boulevard, just south of the 105 freeway, you can see that historic booster, 16 stories tall. It actually looks like a big factory smokestack or something from a distance, but it's actually quite visible, and it's amazing to stand next to. That's the SpaceX factory where it was built.
So that prompted us to start this first of many celebrations of crazy Elon's used rockets, because indeed this was the goal, reusability. It drops the price so much. It makes space development within reach.
And we do this in good spirit. We greatly appreciate everything Elon is doing.
More than
for
good
us.
spirit.
Yes.
We once had somebody say, "Why do you make fun of Elon? We love Elon. Elon, we love you." So please know it is definitely of good spirit.
This same dog appears in a number of things. Is there any reason for that particular dog?
That Doge,
Yeah, it's very Doge.
it was a meme, and one of our staff here, Jeff, just really loves that guy, and so he shows up in a lot of the pictures. But anyway, again, visitors, I could tell you a lot about them all, but I'm going to just point in particular to Alan Stern right here, who is the principal investigator of the mission to Pluto, the New Horizons mission, and David Grinspoon, who is a scientist and author. Both of them have been on the show multiple times, actually, friend to the show. And they're coming back on May 16th for a book signing of they wrote a book together about the New Horizons mission. I am going to tell you, you will want to be here. It is, like All Space Considered, free. There will be a book signing. Buy a book, get it signed by these guys. It's going to be a wonderful night. We will live stream it, but don't worry, but come here. I'm telling you, trust me, I want All Space Considered audience in that audience that night. So we're getting close, 2016. Oh, Prince, we miss you. And just moving forward, that was when we first found the rivers on Titan that I talked about before, and confirmed the plumes coming out of Europa that I also discussed before.
Yeah, we found that exoplanet around the nearest star to us. The Proxima Centauri system is the closest to us, and that planet is in the habitable zone. Now, unfortunately, we learned this year, just in 2018, that it was fried by a flare, that the star got 1,000 times brighter for about 2 minutes and then got 1,000 times fainter. But anyway, maybe the life is still okay, if there is any. Maybe not.
It likes flares.
Maybe it was underwater. Maybe you're under an ice sheet. I don't know.
And it was the year that the Rosetta mission ended. And I have to just show you, well, first of all, before it ended, it saw where Philae landed.
Yes, it did, yeah. So there is with the leg extended out, and there's the whole main body of the lander.
It's not Nessie?
I know, it looks like Nessie, but, and it's so, I'm going to take the time again, because I just, goodbye, dear Rosetta.
So ends the amazing adventure of our two extraordinary explorers, Rosetta and Philae, at Comet 67P. Farewell, dear friends.
I see some people blinking, and I do too. It gets me every time, which goes to say thank you, ESA, European Space Agency, for making that beautiful series.
We'd still be on the moon if we had animated the Apollo missions.
I'm not going to disagree with that.
Okay, moving on. The Juno spacecraft arrived at Jupiter. And when it's close to Jupiter, it flew over its poles and gave us our first ever views of the north and south pole of Jupiter, which you cannot see from Earth. In addition, it provided spectacular images of the Great Red Spot and other storms in the atmosphere of Jupiter. And also this image showing cyclones circling around a major cyclone in one of the poles of Jupiter, and just continues to send back these fantastic pictures of all the interactions and ripples in this massive planet's atmosphere.
Is that Van Gogh?
I know,
Almost
beautiful,
like-
isn't it? Nature, handiwork of nature. Michelle Thaler from NASA headquarters, and Dan Derter won the Carl Sagan Award, called up and said, I'd like to give my speech at Griffith Observatory. We were like, thank you, we'd love to have you. Ken Carpenter, who came from Hubble telescope. So just last year, of course, everybody celebrated La La Land for winning the, oh wait, no. So back to our megastructure.
Yeah, back to our megastructure, that star that kept dimming. We thought maybe it was aliens. Well, it wasn't. Turns out that blue light is scattered preferentially by dust more than red light is. So if it's dust causing it, you'd expect the red light to dim less. Well, they handy color-coded it. That's the red light. That's the blue light. The yellow light is in between. Sure enough, the blue light is dimming more. That's exactly what you'd expect if it were dust. So it's probably dust. It's probably some sort of collision of comets or asteroids or something in the system. Anyway, we'll continue to look at this. It's still a fascinating object, but it's not aliens. It's not.
How many of you saw the solar eclipse? Total. How many of you saw totality?
Yay.
How many of you saw it here at Griffith Observatory? And not totality here at Griffith Observatory.
Yeah, well, that was a trick question.
Yeah, okay, well, it crossed the United States. A lot of people saw it here except for one person.
I got clouded out.
And he had never seen one. So we were very sad for Patrick because it
Next
really
time.
was a beautiful show. And there we are once again, Griffith Observatory with just a few people.
Yes, and earlier I talked about a large iceberg that kind of carved off of the ice shelf, and that was lost in the sea where that's located in Antarctica. Scientists had been observing the fissure that was developing there, and it grew very quickly. Actually, not so fast. We can see the extent of the fissure that was growing in that ice sheet, and eventually it broke off. But it broke off in the middle of southern winter, and it was dark down there, so we had to wait until light returned, and this was one of the photographs taken by a satellite.
We also found a system that had 7 planets around it. They even made a Google Doodle about it. It was such a big discovery. Here they are. And the interesting thing about it, they do orbit a little red star that's faint, but they orbit in just that right spot, that habitable zone, the Goldilocks zone, that we think several of them could have liquid water. And they're all pretty close to Earth-sized. You can see compared to our solar system. They all fit right down in the very, very center. They orbit much closer to their star than Mercury does in ours. But their star is so faint, maybe that's okay. You know, we'll have to see. They all affect one another, tug on each other. We can get masses of them, and sure enough, we learned that some of them do have water in them, quite a lot. In fact, some probably have entire surfaces that are water. Of course, a lot of jokes were said about Snow White and the 7 dwarfs, because there's 7 dwarf planets. NASA released a poster saying you could go planet hopping from one to the other. They're so close together, you might be able to take a weekend journey and see 2 or 3 of them and have a great time. We also found a planet that was so dark that it was labeled the black planet. I thought it might be Gothic. We thought it might have turned to the dark side. So it was a great year for exoplanet research.
And then finally in 2017, we marked the end of the Cassini mission, which was so wonderful and so successful. But before it went away, it decided to do something crazy, which was dive between the planet and its rings. I mean, precision navigation right down the throat there. And so here's a little animation that NASA put out of Cassini going in, and whoa! It was successful. It gave back tremendous amounts of science, but mainly it was the lead up to the end of the mission, which was spectacular because it burned up in the atmosphere of Saturn. And once again, people got choked up. So this is the team. They were extraordinary, good for them. This is the global team from all over the world. They all came to Pasadena, JPL, for the end of the mission, those who could. And we had an event here at Griffith Observatory, and they were part of our event, including the Cassini singers. But just looking at this last picture of you from behind Saturn, and believe it or not, you are in this picture. as are we all. Earth is a little tiny dot. Here it is. So we had a number of wonderful guests once again. Linda Spilker, of course, was the chief scientist for the Cassini mission. Matt Golombek at the lower left came back this time to tell us about where we might land the Mars 2020 rover, and we're going to definitely have him back to talk about that. And again, friend of the show, David Grunspan on the left, who will be here on the 16th of May, so please come and see it. And we had Tim Russ. Thank you, Tuva, for coming to visit, Amy Mainzer, and the director of the observatory. So finally, that brings us up to this year, and the year is just sort of underway. We've had a couple of big things, obviously.
Yeah, we had
the Tesla Roadster, and we all learned that, in fact, Scott Kelly is a cat. Okay, he's not a cat, but there was some
He's
false.
a monkey.
He's a rhesus monkey.
Yeah.
His DNA is still human. Let's just leave it at that. And of course, we said goodbye to Stephen Hawking. So we have exceeded our time, but I'm glad we got to actually go in depth, and you are a wonderful audience to be so interested in it. As always, we are going to end with a couple pretty pictures and then some break videos. The break videos should take you back, and unfortunately, they will be stuck in your head for the rest of the night, maybe for the weekend, but we're doing that to you anyway, because that's just kind of the people we are.